in which it goes through 1 and 0. And like I said, it's the inverse. It's the inverse of the exponential graph, first of all, which means that you switch your x and your y. So you'll notice instead of my y-intercept being 0 and 1, my x-intercept is now 1 and 0. So all you do is you switch your x with your y's. This is the y equals x line. And if you folded it like a piece of paper, they would fold on top of each other. They are mirror images of each other over top of that line. Now in pre-calc, we'll look at that more in depth. What I need for you today is to look at the 4 characteristics or the 5 characteristics versus the 5 characteristics of exponential. And that is this. Number 1, your x-intercept is 1 and 0. Your x-intercept is 1. Okay. The equation of the asymptote is x equals 0. So the asymptote again. So if you watch this graph right here is going to approach this axis but never hit it. So that makes it an asymptote. Same as this guy. The exponential one, this was the asymptote, it would do it. It would approach it but not hit it. Okay, number 3 is the end behavior, and this one is what? This is an interesting one. What's the end behavior here?
1 to 4.
Close.
4 to 1.
Yeah. Yeah. So your end behavior, it starts in quadrant 4 because this is the left side of the graph. It starts down here. So it's in quadrant 4 and it ends in quadrant 1. So 4 to 1. Number 4. The range y is an element of all reals. Goes up and down forever. Goes up and down forever. And then what's the domain for this graph?
X is greater than 0.
Yeah. Okay. So what I want you to do right now is take out the 5 characteristics of the exponential function. And I want you just to compare them. All right, so just take those 5 characteristics of the exponential and look at them. Instead of the y-intercept, it's the x-intercept. Instead of the asymptote being y equals 0, it's x equals 0. This one was 2 to 1, your end behavior. It's now 4 to 1. The range, up and down forever. Y is an element of all reals. And the domain is x is greater than 0. In the exponential, x was an element of all reals, and y was greater than 0. So they're just, again, they're inverses of each other. The equation, the standard equation for this guy is a log x to the base b. Now, let me just have a quick look here. Now, there are, how do I want to do this? Okay. There is a bit of explaining. I want to do this as quickly as possible because we need to move. But, all right. When you look at the exponential equation, I have y equals a times b to the x. So b is what we refer to as the base value. X is the exponent, b is the base value. In a logarithm equation, the base value is a subscript right here. So this is log x to the base b. Okay? Now, I'm going to make this look a little different here. If this was just y equals b to the x, and this was y equals log x to the base b. Okay? I can convert this right here to look like that. But I'm just going to erase this because I don't want you to see that. What happens here is this. To change it to exponential, I take this b and I raise it up to the other side of the equal sign. That becomes my exponent, and then my x stays as is. So to change from logarithm to exponential, I take the b value, my base value, I move it to the other side of the equals, and make that the exponent. So it goes b to the y equals x. And then I can work it back the other way as well. Y equals, and this is going to be a little different. I can go log, that comes down, x base b equals y. All right? Sorry, that's not right. Write this backwards. Y equals x like that. Okay? The x moves down, the base moves down, and then it's the log of y. So this is what you're going to work with this in pre-calculus, not so much in this class. But there is one other thing that you are going to work with, and this we need to know because it's the button on your calculator for your regression. We are going to use, I'm going to change the page altogether here. Instead of y equals a log x to the base b, we're going to use y equals natural log x. Okay, now, this right here is a special case of logarithm. It is the log of x to the base e. Now look on your calculator. Find the ln button down the side. Does everybody see it? Third from the bottom, then the natural log button. Okay, what I want you to do right now is hit second function natural log. So second function ln. What pops up on your screen?
And e to the value.
What do you got? E. What do you got?
Oh, wait, no.
That's the wrong one. You got e to something? Okay.
Yeah.
All right. Let me quickly explain what e is. All right, pi. Pi is an irrational number that goes on forever. Agreed? 3.1415, and it goes on forever. E is also an irrational number. Now, there is a long explanation to it as to how it comes about. But if you put in e to the power of 1, you'll see what that value is. So put a 1 in there and hit enter. So e is 2.718281828, and so on. That's what the value of e is. Okay? So when you see this, the natural log, it means the same as log x to the base e, or log x to the base of 2.7182818. Okay? So that's what this is. When you do your regression, which we'll do in 7.5, you're going to use the natural log regression. So your equation is going to come out as y equals a natural log x, I believe. Let me just make sure. Oh, it comes out. Yeah. It's going to come out like this. This is what your equation is going to say. A plus b natural log x. So that's what your regression graph for this one's going to look like. They do not have the log function as a regression. All right? It is natural log every time, which means you're using base e. So that's all there is to that. So looking at the example on 188, it says y equals 14 log x. It says use the equation to make a prediction, verify your prediction using graphing technology. All right, so let's just quickly look at that. Y equals 14 functions. Oh, there it is. Oh, shoot. Oh, no. I gotta back that up. I just had it and I missed it.
ln.
No, I'm gonna do log for this one because it's 14 log x. The only time you're gonna use ln is if you use the regression graph. So there it is. Log x, close bracket. So there's your equation. All right. Okay. So, first things first. First things first, 14 log x. All right. What is the x-intercept here?
1.
1. It's the same all the time. Okay? That x-intercept is going to be 1 and 0. Now remember, on exponential, it changed when the a value changed. But the a value is affiliated with the y, so that's why it changed. So the x-intercept is 1 and 0. What is the range for this graph? What's the range for this graph?
Y is eliminable reals.
Y is an element of all reals. What's the domain?
X is greater than 0.
X is greater than 0. That's all you need to know. Okay? Again, you've got Desmos. You can use Desmos for those graphs. If you're using regression graphs, use your graphing calculator. If you're graphing equations like this, use Desmos. That's it. Okay? Any questions? Perfect. You get the rest of today to finish to the end. We might as well get to the end of 7.